In this video, we're going to solve two equations using the square root property. In part A, we want to solve the equation 6y squared minus 54 equals 0 using the square root property. The first step in solving an equation using the square root property is that we need to isolate the squared variable component. So in this particular case, we need to get the y squared by itself before we can apply the square root property. So in other words, I need to solve for the squared component. To do that, I first need to add 54 to both sides of the equation. That would give me 6y squared equals positive 54. I then need to divide both sides of the equation by 6, giving me y squared equals 54 over 6 is 9. Now that the squared variable component is by itself, we can apply the square root property. The square root property says if y squared equals 9, then either y equals the square root of 9 or y equals the negative square root of 9. Well, both of those simplify further. The square root of 9 is the same thing as 3. So this is another way to say either y equals 3 or the negative square root of 9 is negative 3. So either y equals 3 or negative 3. So we can check our work. To check if 3 is actually a solution, I'll throw 3 back in for the y in the original equation. So the question is 6 times the quantity 3 squared, then minus 54 actually equal to 0? Order of operations. I have to deal with the square first. 3 squared is 9. Then I need to deal with the multiplication. 6 times 9 is 54. And we do know that 54 minus 54 does equal 0, so this does check out. If we were to check negative 3, to check negative 3 we would do the same thing. 6 times the quantity, negative 3 squared, minus 54, and the question is, does that equal 0? It is important to recognize still we must square, but we are squaring a negative 3, and negative 3 times negative 3 is still a positive 9. So 6 times 9 minus 54, we're checking if that equals 0. Well, you'll notice that's actually the same equation that we just had over on the left-hand side check. 6 times 9 minus 54. We've already verified that that does check. So we do know for sure that 3 and negative 3 are solutions, and so we can state this as a solution set. So the solution set is the set 3, negative 3. In part B, we want to solve the equation 7t squared minus 35 equals 0. It's going to follow the same process. 7t squared minus 35 equals 0. What we need to focus on is isolating first that squared component, that t squared. So we'll begin by first adding 35 to both sides. So we'll have 7t squared equals 35. Then we'll divide both sides by 7. So t squared equals 35 over 7 is 5. And the square root property states if t squared equals 5, then either t equals the square root of 5 or t equals the negative square root of 5. The difference between part A is I cannot simplify root 5 any further. I could still check my work though. To check my work, I would throw root 5 back in for both of those t's. So let's check that real quick. So I would have 7 times t squared, so 7 times the square root of 5 squared, minus 35, and we're going to check, is that equal to 0? The first step in simplifying the left side of the equation is to recognize that root 5 quantity squared means root 5 times root 5, which is root 25. And the square root of 25 is the same thing as positive 5. So in simplifying just the exponent piece of this statement, we end up with 7 times 5 minus 35 is equal to 0. Well, we still know 7 times 5 is 35, and 35 minus 35 does check out to be equal to 0. To check whether negative root 5 is a solution, we'll do the same thing. 7 times the quantity negative root 5 squared minus 35, and we're trying to figure out, does that equal 0? Well, we're going to again begin with the radical component. In parentheses, we have a negative root 5, then quantity squared. A negative times a negative will be a positive, and root 5 times root 5 is still going to be square root of 25. So we're actually trying to check, is 7 times the square root of 25 minus 35 equal to 0? You should notice that is exactly the same step we had in the previous check. Once we square root 5 or negative root 5, the negative is gone and the squared part becomes the same value. So this already we know is going to check. So to finish off with our conclusion, we'll finish off with the solution set. In this case, the solution set is the set root 5, negative root 5.